Welcome back to the channel. Ever wondered how a ship's propeller pushing against massive amounts of water doesn't just shove the entire engine forward inside the hull? This immense force, known as thrust, needs to be managed. That's where the crucial main engine thrust bearing, specifically its thrust pads, come into play. The thrust bearing is typically located either as an integral part of the main engine or as a separate block along the propeller shaft line. The thrust pads themselves are wedge-shaped or segmental components made of steel and lined with a low-friction material like Babbitt metal or white metal. They are arranged around a large collar on the propeller shaft. As the shaft rotates, these pads tilt slightly, allowing a hydrodynamic film of lubricating oil to form between the rotating shaft collar and the stationary pad surface. The thrust bearing and its pads are passive components that are constantly at work whenever the propeller is generating thrust. They are continuously bathed in lubricating oil supplied under pressure from the ship's stern tube or main engine lubrication system. Crew members continuously monitor the bearing's temperature, typically using embedded thermocouples or resistance temperature detectors, RTDs, within the pads themselves. Abnormal temperature readings are the most critical indicator of a problem. One of the most important tasks is maintaining the quality and quantity of the lubricating oil. Monitoring bearing pad temperatures is a continuous and critical maintenance activity. Checking bearing clearances during dry docking or major overhauls is crucial. Internal inspection of the pads for surface condition, scoring, or cracking is essential during planned maintenance. Signs of wiping or blackening indicate breakdown of the oil film. Checking the alignment of the shafting system also indirectly affects the thrust bearing, as misalignment can induce radial loads that the thrust pads are not designed to handle. The primary symptom of an issue with thrust-bearing pads is elevated temperature, especially if it's localized to one or more pads. Other indicators include unusual noises, like grinding or rumbling, or vibrations emanating from the thrust block, and fluctuations in the lubricating oil pressure or flow to the bearing. Their proper function, diligent operation, and meticulous maintenance are not just technical requirements. They are a direct contribution to the overall operational integrity, safety, and efficiency of the ship's propulsion system, ensuring it continues its vital work across the oceans. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more maritime insights. Thank you.